Hey, what's up, guys? It's Mr. Papanik here, working through number 2 in exploration 1 from page 477. Um, Look, we're looking to take this expression, x over 1 plus x, and turn it into a power series, right? So you got to remember every one of these things should look or take on the form a over 1 minus r. If it does, we can actually write it as a power series, right? Where n goes from 0 to infinity of a times r to the n, right? We did this whole bit where we found that if that value r, the magnitude of that ratio was less than 1, the series converged to a over 1 minus r. Right, so we're saying if we can take this expression, x over 1 plus x, and write it like this, in that form, we can actually express it as a power series, and we'll know the sum of that power series, right? So this guy, I mean, it's pretty much in the form as is, right? The x does make you a little bit nervous, but if we can kind of think of that as a value of a, things look pretty good. So we have x over 1, but we have a plus here, super easy to fix, minus a negative x, right? So you have a over 1 minus r, right? So that's telling us that we have the value of a being equal to x, and the value of r being equal to negative x. So we can express this whole thing as a power series. Right, we're going to go from 0 to infinity, and it's a, which right here is x, times the ratio, negative x, to the n. Now this does converge on the interval -1 to 1, right? So as long as the absolute value of that ratio is less than 1, we should be okay, right? So if you're going to be solving these, you'll have negative x is greater than -1, and then you'll have negative x is less than 1, right? When you solve these, of course, you have x being less than 1. You also have x greater than -1, right? So when you put those two together, you still end up with that interval -1 to 1.